This is the place to be to hear about the latest tech trends in healthcare. Today's episode is all about a fascinating and slightly mind-boggling question. Can artificial intelligence predict scientific results better than human experts? According to a study published in Nature Human Behavior by researchers from University College London, the answer is yes. But how? And what does this mean for the future of science and healthcare? Let's break it all down. Welcome into the Meta Health. Let's start with the study itself. Researchers from University College London wanted to test how good both humans and artificial intelligence are at predicting the outcomes of scientific studies. To do so, they created a benchmark called BrainBench. This benchmark uses real neuroscience papers and challenges participants, both humans and AI, to identify the true study results. But here's the catch. The ending of each paper's results is hidden, and participants must choose between two options, one being the actual result and the other a plausible but fabricated alternative. So now imagine you're a neuroscientist with years of experience. You get to read the introduction and methods of a study. Let's say it's about how stress affects memory. Then you're shown two conclusions. One says stress improves memory, and the other says stress impairs memory. Your job is to pick the real conclusion. So this is exactly what 171 neuroscience experts did. But they weren't the only participants in the test. Researchers also introduced a specially trained large language model called BrainGPT. Unlike general-purpose AI like ChatGPT, BrainGPT had been fine-tuned with information from neuroscience journals. Think of it as an AI that went to a neuroscience school for years. And the results, they were absolutely stunning. The human experts got the right answer 63% of the time, which is a solid performance. But BrainGPT blew past them with an 81% accuracy rate. That's like a human getting a B on a test while the AI gets an A. And here, what's even more interesting. The AI didn't just guess based on the results section. It read the entire abstract, integrating information from the background, methods, and the study design itself. This very holistic reading allowed it to spot patterns and make connections that the human brain might miss because, let's face it, no human could ever read millions of scientific papers and remember all the information. This speaks to the unique strengths of AI in fields like scientific research, where integrating massive amounts of data from diverse sources is so important. The researchers noted that BrainGPT didn't just memorize answers, it generalized patterns, suggesting it could identify trends across studies that are invisible to human experts. So what does this mean for the future of science and healthcare? AIs like BrainGPT could help scientists predict the outcomes of experiments before they conducted, saving time and, of course, resources. For instance, in drug discovery, AI might identify the most promising compounds to test, narrowing down millions of possibilities to a manageable few. It's like having a research assistant who's read every paper ever written in your field. You can also imagine an AI suggesting not just what might happen, but how you should structure your experiment to get the most reliable results. BrainBench revealed that BrainGPT excelled as using methods and design to inform predictions, a skill that could drastically improve experimental planning. Third, AI can serve as a bridge between subfields. Neuroscience, for instance, spans everything from molecular biology to cognitive psychology. An AI that's trained on all these areas can help researchers from different disciplines find common ground and work together more effectively. And last, but certainly not least, human decision-making is often influenced by cognitive biases or limited by the sheer amount of information that we can process. AI systems can counteract this by offering predictions based purely on data and patterns, potentially leading to more objective and innovative science. But let's not get carried away. There are challenges too. For example, BrainBench relied on a measure called perplexity to measure the AI's confidence in its predictions. When the AI was more confident, it was usually correct. This calibration is key because it's not enough for an AI to make accurate predictions. Scientists need to understand how and why it arrived at those conclusions. Another concern is that scientists might become over-reliant on AI, potentially discarding experiments that the AI predicts would fail. While, of course, this could save resources, it could also stifle unexpected discoveries, the kinds of breakthroughs that happen when humans take risks and explore uncharted territory. We have a lot of discoveries in healthcare that just come when we least expect them by chance and serendipity, the most famous example being that of penicillin. So that's it for today. As always, I will see you soon for another tech adventure in healthcare.